A good day to each and everyone who and all present here, the respected jury members and also the co-authors, others who have been attending this ISDSA conference. And a brief intro about me. This is Sivaram Varaputhra Kanchi, and undergraduate student currently pursuing my Bachelor's of Technology under the Department of Data Science from an Dr. MGR Education and Research Institute, Chennai, Tamil Nadu, India. Yeah, basically I have been too enthusiastic about the field of EEG, which is known as electroencephalography. And today I'm going to present a conference of a paper which I have been working on from last 2 years. And currently I was a boy of age of 19, still I was in my teenage, and initiated this when I was in my plus one around the age of 16. And then straight away moving on to what the conference which I have gonna present to the respected authors and also the jury members, to all my dear participants here and all, is as we move on to this. Yeah, just a moment. Yeah, basically coming to the title, which is so-called Manu Siddhi. Yeah, before going on moving to the presentation, this is a recorded presentation at ISDSA 2026, July 28 to 31, Beijing, China. Yeah, coming to the presentation part, here I want to clearly tell you the title itself, which is stating an Manu Siddhi. Manu Siddhi is in the Sanskrit language elaborative, which states that a study of brain or an acknowledgement getting related to brain or human brain especially. So the abbreviation of the title is the main theme of the conference of my project or the presentation is cross-model knowledge distillation from invasive brain-computer interfaces to consumer EEG for improved motor imaginary classification. Apart from a long descriptive title, what I want to tell you in simple way is that this project is something which is a cross-model acknowledgement between the invasive BCIs, which are so used in the Neuralink chips, which have been produced or manufactured by Tesla group of companies, and the basic consumer EEG caps, which are known as electroencephalographic caps, which we use basically in hospitals and all for tracking or taking decisions related to brain related concerns or whatever. So apart again, a basic intro of myself is myself is Kanchi Varaputhra, the author of this presentation, and also I'm as an undergraduate student as my own application on the Department of Data Science in Dr. MGR Education and Research Institute, Chennai, India. Moving on to the next topic, why this problem should be used, or why this is the thing. Over 80 million of people are suffering with motor disabilities, lack of functional BC access. The best example of what does it 18 million people is Sir Sri Stephen Hawking, who is a disabled or paralyzed person, but create a remarkable history for himself and remarkable achievements which he achieved in the field of technology. So how come this everything got achieved? Using this same BCA technology. And then currently what we are having is invasive BCIs, which are Uta Array, EGOD or Neuralink. Neuralink is a well-known and highly growing chip right now from the Tesla group of companies, which is being invented by Tesla, Elon Musk, so-called. Yeah. So actually the accuracy of the output which we are getting upon invasive BCAs is 90%. The reason why we are getting so is that the chip is directly placed on the top of a cortex inside our brain. It means that they are doing a surgical operation and placing it, due to which an exact prediction of signals is being taken. So obviously do have the 1024 channels at the rate of 30 kilohertz per frequencies, and also EGO SNR electrocorticography rate is around plus 1.95, whereas the EEG rate is minus 1.969 for the same site, which easily describes that it was having a high accuracy rate, whereas not EEGs. So what are EEGs? EEGs are around having an accuracy of 70 to 55 to 70 percentage, and less number of channels with more frequency heads of 250 plus 250 heads, and then a volume which has been destroys the signals like the external scarf volumes or the environmental volumes and all. So there are mainly two concerns here. One is that there is a bridge gap of 30% accuracy gap and also these volume consensus. So how I gonna tell present you way that how this gonna work is that the related gap which were already existing prior models in this were like simply the EEGs. EEGs are basically the ones which are affecting this, and the prior existing models here are clearly classified here such as CSPs, FBCSPs and remainder in geometries. And there are multiple things which have been already mentioned here, like the EEG nets or deep brain and MIREPNet and also the convolutional net. These are the existing invasive or the EEG models which have been here, and also their architectures have been clearly mentioned here, the linear spatial filters or the SPDF manifold methods or the compact, like whatever it is. So these are the prior methods which have been existing, whereas the accuracy is around only which is lying on the marginals of 60 to 70s. But there are not the cross modules. Cross module is not they're taking an EEG and then comparing with an EEG is clearly which has been known to us. But whereas our Manusiddhi is something like which is the first cross small model. The EEG is the first. Yeah, the Manusiddhi which is ours is the first and foremost cross model which is being done to fill up these gaps, and the architecture follows is the EGNet, Wickham, CKA from Invasive, and which are leading to accuracy of 82.4. This one so blocks have been explained here. Yeah. Coming to what is the Manusiddhi structure overview. Overview is very simple. There do exist four components in the cross module, namely the trained model, VCAM module, testing network, and CK loss. So these will be explained briefly in the next slides. Yeah, moving on to the next. One is what is trained module exactly. Trained module is something like we will be taking the exact BCA signals, invasive BCA signals from the existing public datasets of the patients who have been already inserted with Neuralinks. So we'll be considering the one-dimensional ResNet encoder, which is stable for long waves, and then we'll be encoding these all the multiple signals into a single wave, like a single structure, using ELORITA, which is nothing but exact low resolution tomography. Tomography is a way that imagining something in a 3D view using the 2D structures. So similarly here we'll be considering the like the multiple number of signal waves or the BCA waves from the invasive implants, and then connecting into some particular golden standard trained module or trained model template, like all the wave frequencies and everything will be structured there. So this is the first part we'll be doing here, and then going to what is VCAM and testing network. Coming to the part of this testing network. Testing network are the BCA signals which have been collected from the EEG net caps of the patients, and these are the signals which have been placed in NVIDIA Jetson Orin microcomputer, which is well suited to decode these or encode these signals. And then the thing is that volume conduction alignment module. So VCAM is an gaming environment or a spatial place where we gonna merge these two. And how it's going is that the trained module is being brought into here, the golden template, and then the testing network. These are the things now which are being collected from the like 80 billion people among those. So each subject wise, only any particular individuals testing are brought inside, and both are kept in an environment called VCMM where volume conduction alignment will be done. So how it will be done is that it will be considering the Z invasive value of the golden standard, and then it will be considering the how alignment the subject waves are. So then what it will be doing is that it will be like it will be aligning the subject BCA waves in an exact similar way compared to that of golden standard. I mentioned it both will be similar but not in identical. So it doesn't mean that aligning something into proper format. Imagine a wave was like this in horizontal way. Aligning it into a vertical wave don't change its magnitude. It do change its direction. So the magnitude of the textual values of the waves do remain same. So this is the thing. So why CK here? Why even we do involve CK here? CK is something called center kernel alignment, which you can see here. Yeah, CKA is something so called as centered kernel alignment clause. So what does even CK tell? CK value of the template or the testing model BCI waves from the subjects tells us that CKM distillation loss is something a mathematical value upon considering the left waves or the right waves or how the frequency of the terrestrial values. It will tell you how much rotation do these subject waves need to be done, like how much alignment they should be done and how the alignment should go on, and due to which the accuracy on the Manu Siddhi is taken to say 82.4. Moving to the next. Yes. What does the pipeline looks like? The pipeline looks like the pipeline is very simple. The first thing which we'll be doing is that we'll be taking the pre-training process. Pre-training process is easily involving that we will be taking the all the subject signals and then changing into the golden standard model, and then we will be taking and keeping it in the VCAM spatial space. So that will be there, and then we will be taking the subjects testing signals and we will be digitalizing them using NVIDIA microcomputer, and we'll be keeping both in the VCAM, the spatial environment, and using CK value will make the testing signals into align into way that they look similar to the exact trained module. So this was done. What's going to next? Next is something very interesting. The experimental setup is what I explained here. It's like very clear that we will be considering the epilepsy patients who have been having the chips over their cortex directly, and then considering their channels, and then we'll be creating some normalization score per each and every channel which is been over their cortex. So, and then from the testing EEG evaluation, we'll be taking some subjects and considering the Elorita value, the starting initial point, to take the values from the subjects and then their channels, and then using pre-processing pipeline VCAM, we will be changing the alignment of those testing signals into a way that they look like equivalent to trained model standard alignment using CK values. Like the how much value or how much alignment should be done is completely based on the CKY. And then moving on to next, why we are even clearly stating that our accuracy is 8.4 is because the value so-called Cohen's kappa. Kappa value is something called a statistical mathematical value which removes the probability of A estimation or assuming. So after removing the A estimation or assuming, we are getting an kappa value of 0.76, which is almost 0.2 times higher than the existing baseline kappa value, which is 0.56. So here is the way. The existing methods which have been discussed before are the architectures and the transfer type. There is no transfer at all, and their accuracy is being maintained here. Whereas in our Manosiddhi, the architecture of EEG which is trained model, VCAM, the spatial environment, and CK distillation of how the element should be, is like a cross model invasive to EEG. Like we are taking the invasive signals and then we are transforming it into the EEG, consumer EEGs. And also these EEG considers 8642 parameters under 50 milliseconds per interface. And then moving on to how efficient is this. Like when we are taking up a new subject every time, like new testing model or testing subject, the trained model standard will be same, but whereas the subject might be changing, there is no need to say that every human do have same brain signals. So for each and every new subject, the maximum number of trials the Manosiddhi neurodistillation process reaches is within 12 trials. Within 12 trials, it can predict the subject's accuracy, like what the person is thinking, or it can adopt the new subject to the trained model or the golden standard template. Whereas the existing technologies of EEG to EEG transfers do have 80 number of trials, it is the 12 trials almost 6.7 times less than this. And also, even though at 12 trials also with the accuracy is maintained as 80.1 compared to 68.3, which is far better. And then moving out the attributions of each and every component which have been used in Manosiddhi. Like in a full neuro distillation of Manosiddhi, which is so-called a sweet word of teacher, the standard template, and then we come the spatial element CKA. all together leads to an accuracy of 82.4. Whereas even though if there is no trained model, we are considering only the EEGs of the person and VCAM is voice cancellation also, it is around 68 to 70 margin. And then if you are considering no voice cancellation or the VCAM module and the standard template is around 74 or something. Likewise, each and every component gives a certain percentage attribution to the complete gain of 82.4 or 80 plus is the best way to say upon this. So each and every component in the Manusiddhi do have that. And I'll explain how the mechanic explanation. It's like a left hand signals have been rotated, right hand signals have been stated, and then they will be having the scalp topographies and the volume conductions, obviously on the external sounds. Once we are doing this CK loss considering the Z value of EEG, they will be replicating the distance relationship and construct classifier into neurophysical pulsable subspace, which is nothing but an isometric rotation of the alignment will be happening for the testing BCIs into a way that invasive BCI or the trained model BCIs of cortex plays chip are formed. So that was the architecture maintained here. And then in conclusion, coming to the end of this might be a quick presentation as a speed talk since we have been not showing the biomedical results. In conclusion, what I want to tell or mention you is that the Manosiddhi is as we are aware of, it is the first cross model of for BCI that is directly from invasive recordings to consumer EEG geometric priors. And also CK lato iteramente loss is something which enforces as how much alignment should be done exactly. Like we are not only considering the biological terms but also the perfect mathematical calculations have been followed here. And then VCAM is the spatial environment where the pipeline will be connected or the analyzing process will be done. And then it is something due to which is carrying to 82.4% of accuracy. And then also it is something which is decreasing the calibrate trials for each and every new subject or the testing signals to 6.7 times, which is 12 calibrated tiles. And also the number of parameters it considers is 8642. The parameters are not nothing but the sigma, gamma, and also the threshold values of each and every waves is less than 50 milliseconds. And then the new paradigm, like what is the major advantage of this is that it is rather than investment of Neuralink or ECOG, which have been highly involving more payable things and also surgical things, is better to accessible to these BCI caps which are directly placed over your head under the cost of $300 per dollars and could make more feasible and more connected to those 80 million of people who have been facing this more motor disabilities. And also like a gesticulation block is same as something like at the end I want to tell you only one thing. No matter what we're doing here, the work is not only to improve the number of accuracy from either to 70 to 82.4 or the calibration trials for each and new subject testing signals or from 80 trials to decreasing it to 12. It is not something like which is involving numbers. It completely a project or a product which opens a particular category that how there is no need of a surgical operations which are done to each and everyone. Yeah, we do need to do some surgical operations for the person on to get the trained model. But all this has been done. There is no necessity to do all the surgery for the brain or surgical operations to be done all by the 80 million people. We can deploy this and make sure it's getting this. And then coming to a last point, which states that yeah, thank you. And I want to say to one point which is clearly measured that the Manusiddhi project is something which is not been evolved upon using some prior knowledge. The only uniqueness it is something is that the cross model is it's again mentioned in the thank you slide is that the cross model knowledge distillation for consumer is the motor imaginary classification, like directly from the invasive signals. EEG classification is done by using VCAM, voice conduction is volume conduction is done, and alignment is done, and also the accuracy is being brought. It's like completely opening a new category for the people to help with up. And signing with this, I was signing off, and I was hoping for your discussions and questions. I would be very happy to receive any proposals for the patent copyrights or all the seed money. I may not be clear in this presentation. I might be a bit hurried since it was my first international conference. but yeah, it was something which is working, and I was the one who is leading this project, and and I was very thankful to my institute who have been supporting me in doing this, providing a particular lab session and everything, and would be happy if someone is reaching out us with more number of questions, and we are very happy to share further more experimental documents which have been preserved, which are not allowed to, but yeah, we are happy to share them to whoever interested in. And this was the latest update we found is in June 2026. The last month is the latest research we did, and we were getting an accuracy of 82.4. Yeah, thank you. Signing off. Once again, this is Sivaram Varaputhra from Dr. MJ and Educational Research Institute, Chennai, Tamil Nadu, India. Thank you.